Hi, and welcome to a video on Scatterplots. This is Scatterplots 4, the fourth in a series of videos about regressions on the calculator. Scatterplots 1 looked at how to graph and how to enter data on the graphing calculator. Scatterplots 2 looked at linear regressions. Scatterplots 3 looked at exponential regressions. And for Scatterplots 4, we're going to look at quadratic regressions. For the purpose of this video, we are going to be examining example 7 from Chapter 9, Section 2 of Big Ideas Algebra 1. In this example, we're looking at the temperature during a day. Temperatures during the day, as you probably know, tend to go up and then come back down. So we can see that happens here in our table, which is typical of a quadratic function going up and coming back down. Now, for this problem, it's a little bit interesting because we do have the time set up with AM and PM, which doesn't work with X. I can't have X be 6, and X be 6, again, it wouldn't be a function. As well as I know 6 AM is different than 6 PM. So for the purpose of this problem, I've decided to let X be my hours after midnight. So 1 AM would have X is 1, 2 AM X is 2, 6 AM X is 6, 12 PM X is 12, but then when you hit 2 PM, for example, it's going to be 2 hours after 12, which is a total of 14 hours after midnight. So at 2 PM X is 14, at 10 PM that would be X is 22, and so on and so forth. So you'll need to adjust the PM hours to work with this scenario, is what I've decided to do. So we're going to go ahead and graph our data. If you want a more in-depth examination of how to enter the data and such, you can look at Scatterplots 1 video, but we'll do that briefly together. So I'm going to go ahead and enter my data into a spreadsheet. Go ahead and pause the video right now and enter your data as well. Alright, welcome back, and you can see I've entered my data. I've titled my X as time, and my Y as temp, short for temperature, just like we see the data in our table. I'm going to go ahead and graph this on our graph, inserting a graphing page. Remembering this is a scatter plot, so I need to insert it as a scatter plot. Time, and I gave you that because I did the arrow, temp. There we go. And to view the data, going under zoom, data. And here's my data. It looks very quadratic there in this data. Now we're going to go ahead and do our regression. Now that I've seen the scatter plot as well as entered my data, to do the regression I need to do menu, statistics, stat calculations, and this is a quadratic regression, which we can see is option 6. My X values were time, my Y values for temperature, so X list is X values, Y list is Y values. I've got time and temperature. I use my drop down tabs. Everything else in here is going to just be left the way it is. I hit OK, and here is my regression. Notice, as before, it's got my regression formula written in here, even though it's not in perfect form, but I can see the AX squared plus BX plus C. So my A value, the coefficient of X squared, is negative 0.42. Here's my value for B, which is the coefficient of X, my value for C, and my value for R squared, the coefficient of determination. Notice there is no correlation coefficient given in this one, but coefficient of determination is helpful anyway. It tells me how well the data is going to fit this function. The closer it is to 1, the better the fit. And in this case, 0.99 is very close to 1, so I know it's going to be a very good fit between this function and my data provided. So I want to go ahead and graph this data. I'm going to go back over to my graphing page and going to view that data. I need to switch back to function mode from my scatterplot mode. It is, notice it brought up F2. I want to go arrow up to F1, hit enter, and I see my data there. Now, of course, the data is not perfectly on the line, but there's a very, very good fit there between this function and my data. Now, here's where you can see a variety of application problems coming up about the scenario we're looking at, which again is the temperature during the day. Let's say, for example, they ask you to predict the temperature. Maybe they ask you to predict the temperature at 11 p.m. Well, if I'm predicting a future temperature, I'm going to use my calculator to do that. So I'm going to go ahead and insert a calculator page. I want to know the temperature at 11 p.m. And as I said earlier in the video, my X is hours after midnight the day before. So by 12 p.m. I'm at 12. Going up, 1 p.m., 2 p.m. instead of to 11 p.m. is another 11 hours. So 12 plus 11 is 23. So I'm going to go ahead and find my function at when x is 23. It tells me it's 46.866 degrees. So that would be the temperature at 11 p.m. Sounds pretty cold. Another thing they might ask you to do is find out when is the maximum temperature. If I want to find the maximum temperature, I would go ahead and use my analyze graph to find the maximum. For example, when is it the hottest during the day and what is that temperature? And there's my maximum temperature on this function. Looks like this is my time and my temperature would be 83 degrees. To interpret this time, and remember again, x is hours after midnight, so at noon, when we're counting by PMs, we restart. So 13.8 would be 1.8 hours after noon. So at 1.8 p.m., which I would then want to change over, okay, 0.8, 0.8 times 60 minutes in an hour would be 48. So at 1, writing this out, it's not going to mean anything on the calculator, but at 1:48 p.m. is when it would be at a maximum temperature. That's another application scenario. A third one may be that they ask you, at what time do you have a certain temperature? Well, if they say, at what time do you have a certain temperature, so in an example in this problem, we are looking at what time is the temperature 77 degrees Fahrenheit? Well, temperature is a y value, so I cannot use my calculation, my function notation here, because this is the x values that I enter in there. However, what I can do is graph a y value. So if you hit tab to bring up your graphing screen, remember f of x is the same as y. When is y 77? I'm going to type in 77 degrees Fahrenheit right there. I hit enter, and I can see, okay, this red line represents when I'm at 77 degrees Fahrenheit. Well, this is my temperature during the day, so see it's at 77 twice. So I really want to know what are those two times. To get those two times, I need to find the intersection. There's a more intensive video on how to find the intersection you can look at another time, but very briefly, to find the intersection of the two lines, I'm going to go to Analyze Graph, Intersection, and find those two values. Analyze Graph, Intersection, lowers left, uppers on the right, and this number is a little hard to read. Let's move it over here out of the way. And there are my two times, okay, that I'm at 77. 10 would be less than 12, so that's 10 a.m. 17.5 is more than 12, so subtract 12 and I get 5.5, so at 5:30 p.m. So 10 a.m. and 5:30 p.m. I'm at 77 degrees Fahrenheit. And that is how we can do a quadratic regression, as well as some of the potential application problems that you may see.